ladders. Yep, those exist, but how do we make our AI know how to use those ladders to traverse the verticality that we put into our levels? In this video, we'll unlock the secrets of NavMeshAgent ladder traversal. Hey, Chris here from LlamAcademy, here to help you. Ooh, me? Yes, you! Make your game dev dream become a reality by helping you make your AI be able to traverse those ladders on your well-designed levels. If we take a look at a ladder and conceptualize it in the Unity navigation system terms, we can see it's simply connecting two disjoint nav mesh areas, or potentially not disjoint, they're connected from a long way away, and we want to provide a way to go from one to the other. We do that with something called an OffMeshLink, and in the editor we configure those OffMeshLinks using the component the NavMeshLink. All the way back in AI Series Part 2, I covered this, so all we have to do is slap a NavMeshLink on our ladder and we're done, right? No, that's not right. The real trick here is configuring how the NavMesh agent traverses that OffMeshLink to make it look and sell the effect of climbing the ladder. We can take control of that OffMeshLink traversal by setting the agent auto traverse OffMeshLink to false. Our agents will still get on the OffMeshLink, but then it becomes our responsibility to move the agent however it needs to move over that link. So I think you can see where we're going to go with this. We can do a scripted sequence of mounting the ladder, climbing up the ladder, climbing off the ladder, and then saying agent.complete OffMeshLink, which tells the agent to take the endpoint of that link and give control back to the NavMesh agent. Now, I'm not a super animation guru, so you can still see a little bit of jank here and some additional polishing that can be done, but I think this gives you the foundations of what you need to be able to perform this operation, and I'm sure you can do a lot better job polishing it than I've done here. Let's walk through that together now. We can see here we've got this super high quality ladder modeled with ProBuilder, and we're going to want our dude to be able to climb that ladder. If we click up there right now, he runs all the way around up the stairs and eventually makes it to the top up here. And to go back down again, he's got to run all the way around. It's not really convenient for him. So he'd prefer to be able to climb up and down this ladder. So let's start with our ladder. The only thing we really need to do here is attach a NavMeshLink. We already have a baked NavMesh with areas on top and on bottom. So let's just, in our hierarchy, create a new game object and call it NavMeshLink. Attach that component, NavMeshLink. And this component attaches an OffMeshLink in the navigation system, saying you can go from the start point to the end point. Using the gizmos here, we can position the start point to the bottom of the ladder on the NavMesh, somewhere like here. And that's going to be the position that our agent or the dude is going to take. Same for the top. We're going to want to pick a position on the NavMesh that he should climb to. So that's going to be the start point if he's on top. And this is going to be the start point on bottom to climb up and down. We're going to want a dedicated area type for the ladders. So let's go to our area settings, make one called ladder and give it a cost of 5 because climbing up and down a ladder should be relatively expensive. If we have short ladders and the agent can run around instead, it's probably going to be faster to do that than to do our whole little scripted sequence. On our NavMeshLink, after we've set up that area, we can assign it to be the area type ladder. That's it, we've set up our ladder. Pretty straightforward. The next component is on the dude is our animations. This is extremely important. The dude comes with some idle and move animations out of the box. Those are included in the repository, which, by the way, this full project is on GitHub for free, minus what I'm about to say. The ladder locomotions, I didn't have a good free source of ladder animations, so I'm using this pack from Protofactor, the Ultimate Animation Collection, which I think is a phenomenal animation pack. I've got a link in the description to that. I picked up on sale a while ago and I've just been using it constantly since then. It's got every type of animation that I'm ever looking for included in that one pack, and they all look really good. So how this works is we just toggle between a blend tree of move with all of these different potential run in place, run at a turn, run backwards, all that kind of stuff. And we pass the velocity X and Y of our agent into this tree and it handles that blending. If we are moving, then we move over here because we don't want him to be running in place if he's not moving, we want him to be idle. Now for the ladder, we've got a parameter called isOnLadder. As soon as our agent starts taking this NavMeshLink, we're going to set this Boolean to be true. Then we're going to pass off the animation, so we're not going to run, we're not going to stand idle, we're going to start doing the ladder locomotion. You'll also see this ladder direction, which is going to tell us if we're going up or down. So if we open up this substate machine here, And I made it just go to this router node that has the idle animation, and just having an animation that looks natural will prevent your animation from getting broken. I initially had this as no motion attached, and you could tell that it didn't look quite right. And if the ladder direction is greater than 0, that means we're going to go up. If the ladder direction is less than 0, that means we're going to go down the ladder. So down here, our ladder direction is going to be a positive value, so we're going to go up. Up here, if we want to climb down, it'll be a negative value, so we'll climb down. And we've got these little animations here where they'll jump onto the ladder. So this is enter ladder bottom unarmed, root motion. Then we are going to transition into climb up ladder, where he'll climb up that ladder, and that's a looping animation. And finally, he'll exit the ladder on top. And there's the inverse of those climbing down. We're not going to go over and just preview all those animations, but that's this chain of animations. We'll enter the ladder, climb down, exit, or enter, climb up, exit. Once we've exited and completed this animation, we'll go exit, which will transition us back into either idle or move, depending on the rest of the parameters that we have here on the animator. So the animations are a key part of this, and you'd probably also want to attach some IK to have the hands directly grab these ladders. These animations look really good, but it's not quite perfectly matched up. So with IK, you can do the small corrections to make it look flawless. I guess the last thing to talk about here is how do we transition between each of these, because I did spend some time making that look good. Depending on your animations, you'll play with different settings here, but very importantly, our enter ladder transitions have an exit time. So we're going to play this whole animation and then start getting into the next climb up. So based on your particular animations, you may have slightly different settings than what I have here, but we do want to have exit time because we do want him to play the whole animation before he gets on the ladder. And then in here, we only exit if is on ladder turns to false. So we'll set this animation parameter as we're traversing our OffMeshLink here, set to false once we get to the top, give him time to transition and play this animation, and then exit and give back control to that NavMesh agent. That's our algorithm here, basically. Now let's take a closer look at the scripts on the dude. So far on the dude, we've just got a NavMesh agent, a player movement with just simple click to move. I've covered that in AI series part 1. So if you're not sure how to do click to move, I'll have a link to that video in the description, and this agent link mover. And we're going to cover how this works. I went in depth on this on AI series part 17, but if you haven't watched that, don't worry. By the end of this, you're going to know exactly how it works and how you can extend it yourself. Let's hop into our agent link mover. If you've never seen this before, don't worry. Even though it looks like there's a lot of stuff going on here, it's really pretty simple. And you can download this whole script and just take it off the shelf from the GitHub repo. If you don't have to type all this because there's, 100-ish lines of code, you probably don't have to type all that. On awake, we grab a reference to our NavMesh agent. On start, we've converted start to a coroutine. We're turning off auto traverse OffMeshLink because we want to control how does the agent traverse those OffMeshLinks. Otherwise, the navigation system does like a normal speed movement and it looks kind of stupid for ladders. If the agent is not on an OffMeshLink, we're not going to do anything. We're just going to keep waiting for the next frame and check if we're on the OffMeshLink. So we're polling every frame, are we on that link? Now, if we are on an OffMeshLink, this is where you start seeing like a lot of stuff going on, but it's all basically the same thing. We get the OffMeshLink data, which very importantly has the start and the end position of the link. That's really what we're looking for. And those are vector 3s. We can get the NavMeshLink itself from the agent.navmesh owner. And we care about the link because we want to know what area type it is, because we want to traverse the NavMeshLink areas differently. Remember, we configure this ladder to be a ladder type. So what we're going to add to this is when this link area is ladder, we're going to do a different movement type than anything else. We do a distance check here just to find out which end of the OffMeshLink we're on. I found that this helps us when we have multiple links that are close to one another. It prevents the agent from hopping back and forth over these links. Then we want to find which NavMeshLink traversal type, which we configure in the editor. It's simply a mapping from our OffMeshLink move method to the area type. And an OffMeshLink move method is an enum of supported move methods. So out of the box, if you took this from AI Series 17, you'd have exactly this code where we can take NavMeshLink's teleport, we can move at normal speed, we can move in a parabola, or we can move on a curve. Now we're going to add ladder, because that's our new case, right? So we're going to find which configuration we're going to follow. And all of this is just if we're doing the normal speed or our default move method is normal speed. So this is really just figuring out which type of movement we're going to do. And we start a coroutine to handle that movement. Remember, start is a coroutine here. So you can yield return start a new coroutine, and this start coroutine will wait until this new coroutine completes before it executes anymore. So that's a cool way you can like nest coroutine execution like that. We've got some events. You can call onLink start, onLink end, and subscribe to when the link starts and ends in your other code to do whatever you want to do. So all this is doing the exact same thing, just moving the agent based on our offLink move method. And whenever that other coroutine has ended, we call agent.complete offMeshLink. That transfers control back to the NavMesh agent saying, hey, we're done moving you. Go ahead and keep doing whatever you do, NavMesh agent. So we're going to want to do basically the same as one of these. So I'm going to copy paste. If our move method is the move method ladder, or the configuration is null and our default move method is the ladder, we'll raise those events whenever we start and end, saying we're doing a ladder movement. And we're not going to move a curve. We're going to do move ladder and provide the offMeshLink data. So even if you don't want to take the whole AgentLinkMover, the core thing you need is this bit, yield return start coroutine move ladder, agent complete offMeshLink, if that's the only type of offMeshLink that you're going to have. That seems unlikely, so I would recommend you take the whole thing, but if you only have ladders as offMeshLinks, you can just do that. Now let's come down to the bottom and define that. Private IEnumerator move ladder. And of course that accepts the offMeshLink data. And the very first thing we're going to do in my case is I want to disable root motion. We can keep it enabled if you have really perfectly aligned ladder climbing animations. You don't have to do that necessarily, but I'm going to move this transform instead of letting root motion do that. So I actually need to get a reference to the animator before we can do anything here. So up here at the top where we have the private NavMesh agent, I'll get a private animator, and on awake, I'll get a reference to that animator. Coming all the way back down, I'm going to disable that root motion. And I'm also going to tell the agent, don't worry about updating the position or rotation. If we don't disable update position and rotation, this kind of gets messed up. Now from earlier, you remember that we need to tell the direction of the ladder. So we can define a float ladder direction with data.endPositionY minus data start position.y. That'll give us a positive number if we're going to climb up and a negative number if we're going to climb down. Now we need to know where in the world are we going, because we have two cases. We can climb up or down, right? So we need to know, do we start at the start position or do we start at the end position? Let's define the ladder start position to be the data.start position. But remember, we can climb up or down. So really, if the ladder direction is greater than 0, we want to use a start position. Otherwise, we want to use a data end position, because we're going to go from the start to the end, regardless if we're going from the top down or bottom up. And just a little warning, what we're implementing here right now is not going to work exactly right, but I really want to show you why this doesn't work before we get into the more complex solution to solve it correctly. If we do it correctly right here, it's really not going to make a lot of sense, and it's going to seem a little overcomplicated. Similarly, the ladder end position should be the inverse of that. So we'll take the end position if the ladder direction is greater than 0, or the start position if it's less than 0. Now we want to know the ladder forward. And this one can be a little bit tricky because we want it to be pointing straight in one direction on the Z. In our case here, right, we want it to be the Z forward, but potentially our ladder could be this way, which would again be not the world Z. So we need to find out based on the direction that our NavMeshLink is going. Hey, in this case, we can see it's going to be the Z forward, which means we can take our end position minus our start position as if they were on the same plane on the Y, and that'll tell us what the forward should be. But again, we have to consider, are we going up or down? So we can do ladder direction greater than 0, and we'll do a new vector 3, taking the data end position X, 0 on the Y, which is an arbitrary value. It doesn't really matter what Y value you use as long as we're consistent on that. And the data end position Z, minus a new vector 3, doing the exact same thing just with the start position, X, 0, and the start position Z, and we do dot normalized on that. So that'll give us the end position minus the start position on the same Y plane. And we want to do the same thing, just inverted in the other case. Now we've calculated our start, end, and forward positions. The algorithm we're going to follow is we're going to move the agent to the starting ladder position because they might not quite be there. Then we're going to make the agent look at the ladder forward, so they're going to play the animation correctly and they won't climb up like the air. We'll play the animation to mount the ladder, wait for that to complete so the agent will be mounted on the ladder, and then we'll move towards the end position at a reduced agent speed. Once we've made it towards the top of that, we're going to dismount, and again, wait for that to be dismounted, and finally, re-enable the root motion and update position that we disabled at the top. So we can see that this is not quite as simple as mount ladder. There's a lot to do to make it smooth. So if we want to move the agent, we're going to want to wait again. We can yield return to start coroutine, move to target at normal speed. This happens to already be a coroutine that we defined for moving at normal speed. It looks like this. We just do a distance check between the agent and the target, make sure we're within stopping distance. And if we're not in that stopping distance yet, we do vector3.move towards that position based on the agent speed and time.delta time. Very straightforward here. Once that coroutine is completed, we're going to want to look at the ladder forward, which again should probably take multiple frames. So we'll yield return, start coroutine, look at target forward, providing it with a ladder forward. Let's go ahead and make that. Define it as a private IEnumerator, look at target forward that accepts a vector3 forward. To look at the target forward, we just need our target rotation and our current rotation. We can do that by quaternion target rotation equals quaternion.look rotation forward. We can get the starting rotation with quaternion start rotation equals agent.transform.rotation. And we'll just do a fixed time lerp here, saying float time equals 0, while time is less than 1, agent.transform.rotation equals quaternion.slurp, start rotation, target rotation, time, and have time plus equal time.delta time times 4. So we make it be 1/4 of a second to look at that forward. And of course we yield return null, so we do this once a frame. And I like to always set the agent transform rotation to the target rotation at the end of any of these lerps, just in case we were off by a little bit. Now we've moved the agent to the starting ladder position. We've looked at the ladder forward. Now we want to play the animation to mount the ladder and wait for the agent to be mounted. Remember, we said that we do that by setting a Boolean on the animator. So we can do animator.setBool, and it was isOnLadder, but writer tells us accurately that this is inefficient. We should use a cache property index. I've already made a class called animator constants. So let's go ahead and do that. Having a public static int isOnLadder equals animator.string to hash isOnLadder. And we'll go ahead and make the one for ladder direction as well. Public static int ladder direction equals animator.string to hash ladder direction. The animator does this under the hood if you just provide a string. So this is a more efficient way of doing that. Back over in AgentLinkMover, we can replace that string isOnLadder to the animator constants int isOnLadder. We can then wait for 1 frame to let the animator update. So they start mounting the ladder. And then we want to wait for the duration of this animation, but we don't really know what that animation is right now. And I tried to do some of the animator, get current animator clip info, but with the blending, it wasn't really straightforward on doing that. So instead, I decided to make just a little struct that has the animation clips as fields that we can reference for the top mount, top dismount, bottom mount, and bottom dismount. At the top of the agent link mover, we can just say private ladder animation info, ladder mount info, and make that a serialized field. So in the inspector, we can assign which clips are for which thing. And then it works with any of your animations and you can change them out and it should still work without any code changes. Back down in our move ladder coroutine, we can yield return a new wait for seconds based on the ladder direction. So if the ladder direction is greater than 0, if we're going up, we want to say the ladder mount info dot bottom ladder mount dot length. That'll tell us the length of time in seconds that clip is. And then we have the, of course, other case where we're climbing down. We want to use ladder mount info dot top ladder mount dot length. Now our agent's on the ladder and we're going to want to move the agent up the ladder. So we're going to do that very simply with something similar to move to target at normal speed. We'll yield return start coroutine, move on ladder, providing the start and the end position. We'll move that below our comments so our comments are accurate. Let's go ahead and define that coroutine with a private IEnumerator move on ladder that accepts a vector3 ladder start position and a vector3 ladder end position. And here we're going to do something very similar to move to target location, but we're going to move more slowly than the typical agent speed. We'll start with the float normalized time, and we'll define a float speed with the ladder start position minus the ladder end position dot magnitude. That gives us the length of that vector, which we can think of as the distance we're going to travel. Divide that by the agent speed, that'll give us how long it should take us to get there, and divide that by an arbitrary value of 6, which you could put in the inspector as well to tweak how this works in the editor. Then we're going to just do while normalized time is less than 1, lerp that agent transform position from the start to the end position with the normalized time. Then of course, increment normalized time by time.delta time times that speed, and yield return null to wait for the next frame. At the end, after we've completed the lerp, we'll go ahead and set the agent transform position to be the exact ladder end position. Now we've moved on the ladder from the start to the end position, so now we need to play an animation to dismount the ladder and wait for that agent to be dismounted. We do that by just adjusting some animation parameters and basically doing this thing again about the wait for seconds based on the ladder direction. But instead of the mount, we want to use the dismount. So if we're on the bottom, ladder direction greater than 0, coming to the top, we're going to want to use first top ladder dismount length. And if we're coming down, we want to use bottom ladder dismount.length. Before we do that, we want to set those animator parameters, animator.setBool, animatorConstants.isOnLadder, false, and animator.setFloat, animatorConstants, ladder direction, 0. And it looks like we actually missed setting our ladder direction earlier. So whenever we're getting on the ladder, we'll go ahead and set that direction as well, just before we wait for that animation to play. If we don't set this, then whenever the animator's playing, it's not going to know the right way to go, and it's going to stall out on our router node for this duration, and it's going to look a little bit weird. Great, we're almost done. The last thing about re-enable root motion, update position and rotation, we can just copy paste what we did at the beginning, but invert it. Apply root motion. Because I am using root motion, we'll turn that to true. If you're not using root motion, of course, you don't have to mess with that part. Because I am using root motion, I'm not going to update the position automatically. The animation handles that along with my player movement, and update rotation I am going to want to be true. I think that should be all of our code here. So let's go ahead and hop into Unity and try this out. But remember, it's not going to quite work right because I forewarned you earlier. You have to do something more around these ladder start and ladder end positions. But I want to really show you why that is before we start doing more complex stuff here. First, our dude, we've got to hook up our ladder mount info. We've got enter ladder bottom unarmed. That's going to be bottom ladder mount. Enter ladder top unarmed. That's going to be top ladder mount. Come down to the exits. Exit ladder top unarmed. It's going to be my dismount on top. And we want to find the bottom. Exit ladder bottom unarmed is that bottom ladder dismount. And again, if you're not using this specific animation pack from Protofactor, you just need to hook this up with whatever mount animations you have based on the direction they're going to be climbing. Our NavMeshLink traversal types, I'm going to add 2. We'll do normal speed. And for our second one, ladder. And our area type is going to be 3. We can tell what that is by going to the window AI navigation. Areas, we've got built-in 0, 1, 2, and 3 is where we have ladder. So that's why we're mapping the area type 3. And then if we click play, move the dude over here to the ladder, click on top, he mounts it, starts climbing, but he phases through the wall and then dismounts, and then he's at the end and is okay. Coming back down, he kind of doesn't work correctly at all. So there's definitely something wrong here, and it has to do with those start and end positions. So coming back to our agent link mover, in this move ladder, these 2 start and end positions are really our key problem here. We tried to do it too simply and it just doesn't work right. The start position we saw worked totally fine. This was great. However, the end position, we want to manipulate this a little bit. So what we really want to do is conceptualize our start position as the start position on the floor and conceptualize our end position as the top of the ladder. If we conceptualize it like that and consider that we want to climb straight up and down, we can see that we need to manipulate our second value to stay on the floor but keep our data end position X and Z. Then for our end position, we can use the end position in the else case, but in the case that we're climbing up, we can remap our start position to keep the X and the Z, but take the data end position Y. Now the start position and the end position will be properly synchronized directly above one another. With that, if we hop back over into Unity, click play, send the dude over to his ladder. There he goes, he gets aligned, mounts, starts climbing up, gets to the top, dismounts, and looks good. Coming back down, he'll mount, start climbing down, and dismount. So what's left here is the polishing. We can see as he's mounting, he actually climbs up a little bit and then teleports back down to the base of the start position. And then the rest of his animation looks pretty good. Maybe the top dismount could use a little bit of work so he doesn't phase through the ladder. That could also be solved by shortening the ladder probably. There's a little bit more polish work that we could do on the top to get him mounted onto that ladder as well. But from here, we have all the basics that we need to be able to make a really smooth, nice climbing ladder animation. And just for fun, if we click over here by the stairs, the dude knows that it's actually faster to run around than just to climb the ladder when we're going near the stairs. But the farther left we click, he's like, okay, yeah, the ladder's going to be faster, and he'll climb up that ladder. The key takeaway here is to do ladder traversal, we're really doing a scripted sequence to have the agent get in the right position, climb that ladder, and then perform the off-mesh-link. This gives our AI the ability to do that in a consistent manner that looks pretty good. Now, like I said at the beginning, there's still some jank here. I haven't done all of the polishing, but I've given you the framework and the steps and all the things you need to do to get a really polished animation looking here. Some tips to make this really perfect are to use an IK tool like Final IK or Interactor to add that IK to make sure the hands are going right there on the bars and so are the feet. Both of these assets I've covered before, and they both provide really awesome tools to accomplish this. I'll have links to both of those in the description as well as a video where I covered them. This is a video I've had in my backlog for years now, and I'm really excited to finally put it together for you. If this was cool, helped you out, and you got value out of this video, make sure you've liked and subscribed, and go ahead and share it with someone who you think will also get value. That helps me out tremendously. Now, if you want to show your support for LlamAcademy, there's a few ways you can do that. You can get yourself some LlamAcademy merch right here on YouTube. You can use the affiliate links down in the description, like if you were going to pick up Final IK or Interactor, or even the Protofactor animation pack that I've been using in this video. If you use the affiliate links down in the description to do that, that really helps me out. You can also become a YouTube member or a Patreon supporter. Both of those will get your name in every repository that comes out while you're a supporter, as well as access to a private members exclusive Discord, and your name appear at the end of every video. At the awesome tier, there's Ivan, Iphiopoulos, Mustafa, and Snedden. And at the supporter tier, there's all of these great supporters as well. Thank you all for your support. I am so incredibly grateful.